660, whatever. So just half times whatever this angle is. What about this one? This one is going to be, as we said, how much?
360 minus x.
Okay, so this is 360 minus
6.
I want to write it like here so that you guys can see. Okay, 360 minus x. And these are all in degrees. I'm not putting the degrees. Okay, so notice this was facing like this. So look at the angle subtended over here. It should be facing like this. Now this is the angle that is facing like this. So its subtend should be here somewhere. So what should be this angle? This is the angle at the center, which measures this much. So what should be the measure of this angle?
Half of 360 degree minus x.
So yes, exactly. So it should be half times
Half times 360 degree.
360 minus x. And which if you multiply, if you distribute, you will get 180 minus half x.
Yes.
Because it would be distributed. Okay. Now notice, we have this quadrilateral. Forget about these lines. Isn't this a quadrilateral?
Mm-hmm.
So now let's check. If we add these two, is there some 180? So let's name it A, B, C, D. So let's add the measure of A to measure of C. What is the measure of A?
Is 1/2 360 man.
So which we computed over here?
180 degree minus 1/2 x. 1/2 x.
And what is the measure of C?
1/2 x.
These two will cancel, additive cancellation. What is their sum?
180.
Oh,
Yes.
isn't that amazing?
Mm-hmm.
We didn't even do anything. We applied our previous principles and we came to conclude that, okay, it doesn't matter whatever quadrilateral we have, if it is inscribed in a circle, the opposite interior angles will be supplementary. The sum of these two will be 180, the sum of these two will be 180 also.
Yes.
Okay, so any questions about it?
So can you help me? Because question number 1 on page 796.
Very good, very good. That's what we are looking for. Okay, so that would be, so turn on to page 796.
Okay.
Okay. So let's try to do it. Thank you.
Yo.
So this is what it is. So they're saying find the value of x. You know, my drawing is not good. I can't draw it really well, but that's fine. This is M. So J, K, L, M. They're going clockwise. Normally that's not the practice, but we'll let them do it. It's there. The measure of this is 20x over 3. The measure of this is 6x minus 15. And the measure of this is 39 plus 7x. Okay. Can anyone tell me what should be the key steps that we should do and try to find what is x? So the question is find x or solve for x, it doesn't matter. Okay.
We can add 6x minus 15 and 20x over 3 equals to 180 because those are the opposite. So they
Are these two opposite?
No.
Okay.
So J and L. 39.
Exactly.
J and L.
Okay.
Measure of
So
angle is J and L.
exactly. Applying our theorem, measure of J plus measure of L should be equal to
180.
180. That's the argument. Okay. And notice whenever you do mathematics correctly, you can solve a lot of things. Okay. So J is 39 plus 7x
7x
plus 16x minus 15 equals to
180.
Okay, using your mathematics of algebra. Yes.
It's not 6, it's 6x.
It is how much?
6x minus 50. It's not 16.
Oh, thank you for correcting me. Thank you. You know, even with the glasses, I am blind, so don't worry about that.
It happens sometimes.
Yeah, to me most of the time. So, okay, so let's add these two. These are two like terms.
13x.
13x, very good. You want to come up and do it? Come on.
Okay.
Finish it up. You can move the constants to the other side.
Yeah.
Very good. Okay. So the sum of these two, 195 minus 39. Okay, so we have. No, that would be wrong. No. So, yes, subtract that. So you will get 6
Yes.
and then 5, 1, I think so. And you have 13x is equal to 156. And that is why I would suggest always go vertically down.
Exactly.
Then you don't have to do logical. I mean, someone who's reading would automatically see, oh, so this turned out to be 156.
56.
And computation is right.
Okay.
Okay, but then over here it is very obvious. Okay, if 13 times something equals 156, then if I divide by 13,
Yeah.
I'll know
12.
x is. Did you say
12?
12? Okay,
Yeah.
great. So x is 12 degrees. Okay. Great.
Yes.
Question. So you see, there is immediate application. Okay. So not only can we apply this theorem to solve these problems that are just geometric in nature, but at the same time, it is a very, very helpful tool in construction. Let's say this is a very common pattern. If you turn to page 797 in your book, they want us to construct an inscribed square. How do you construct that?
Same way you do the inscribed quadrangle?
Yeah, but remember, in a quadrilateral, you don't. So square has all four sides equal. Not only that, remember, you could have a four-sided figure that has equal measures of the sides. What do we call this figure?
Parallelogram.
Yeah, but in a parallelogram, the opposite sides are equal in length.
Quadrant.
Yes, it is a quadrilateral. All four-sided figures will be quadrilateral. It's something else. Have you guys heard this word?
Rhombus.
Rhombus.
You got it now.
Yeah, so very good. In a rhombus and a parallelogram, this is the key difference. So a rhombus is also a parallelogram. So you're not like all the way wrong, but at the same time, the opposite sides are equal. So this is a parallelogram, but this is not a rhombus. Both of them are parallelograms. Yes, you have a question?
So it's like in kindergarten they taught that that was a diamond, but it's actually my teacher. She told me it was a rhombus.
That is good. That is good. It is a rhombus. Okay, that's
It's
what
not a
we
diamond.
call it, a two-dimensional geometric figure. Okay, so now remember, not all four sides have to be. So definitely all four sides have to be equal, but at the same time, the interior angles all need to measure how much?
90 degrees.
90 degrees. Okay, so here's the method how you draw a square inscribed in a circle. Okay. So you know where the center is. First you draw a circle, you know where the center is, pass a line, it doesn't matter at what angle, pass a line which would be basically, what is this called? The one that passes through the center and touches the two sides of the circumference.
Diameter.
Diameter, very good. Okay, so we mark this center, and then you need to have a compass. okay? And open the compass so that it is more than the center, but not equal to the diameter. It could be less than the diameter, or it could be more than the diameter. Is that clear?
Yes.
Oh, yeah, it can be more than the diameter, or it can be less than the diameter, but it has to be more than the radius. Okay, so let's say if I open it where it is of this much length, a little bit more than the radius. So if it is like this much long, what would happen if I draw a curve? It would be somewhat like here, and one arc over here.
Yes.
Do you guys agree?
Yes.
Yeah.
And then I go to the other side and do the same thing.
Yeah.
So I have here